Hello everyone, I am Abhijit Bhattacharjee from University of Saskatchewan. Welcome to our paper entitled An Exploratory Study to Find Motives Behind Cross-Platform Forks from Software Heritage Dataset. One of my co-authors is from Carnegie Mellon University and others are from University of Saskatchewan. The fork-based development mechanism allows people to copy an existing code base and start an independent development. It provides the flexibility and the unified processes for software teams to collaborate easily in a distributed setting without too much coordination overhead. Currently, multiple social coding platforms support fork-based development, such as GitHub, GitLab. Although these platforms virtually share the same features, they have different emphasis. Most of the prior studies about forking focus on GitHub, although GitHub is the most popular platform that supports fork-based development. Other reasonably popular platforms also support the fork-based development mechanism as well. With the advances of the software heritage dataset, which brings different social coding platforms data under single roof, including GitHub, GitLab, Debian, and PyPI, we have the opportunity to study the forking activity among different social coding platforms. Anecdotal evidences show that people are struggling about which platform to choose for software development, and we observed projects migrating from one platform to another, such as the project Vim was hosted on GitHub and then was moved to GitLab because of the continuous integration feature of GitLab and was renamed as MG-Vim. In this study, we would like to understand why developers prefer one platform over another. Specifically, we ask two research questions. First, how frequent are the cross-platform forks? Second, what are the reasons behind forking? To answer our research questions, we followed mixed methodologies which combine quantitative and qualitative analysis. For quantitative analysis, we retrieved commits of our target systems from the dataset, mapped other projects which point to the commits. Next, we filtered cross-platform forks by URL to answer research question 1. Later, we manually investigated cross-platform forks to categorize them according to motive to answer research question 2. As we know, the forks of our subject systems from GitHub, here we reported the number of forks from GitHub we are able to detect to validate our fork detection mechanism. In total, our approach detected more than 80,000 forks. From all the forks detected from software heritage dataset, we filtered the cross-platform forks. For our 10 subject systems, we have been able to retrieve 179 cross-platform forks. We manually compared cross-platform forks with their upstream projects. We categorized them in 5 categories. Many of the cross-platform forks are created using mirror feature. Another category is the original repository's contributor had a copy in another platform. Few forks we found which title are renamed after forking for different purposes. Another kind of forks show no activity or pattern after being forked. Some forks are due to using different functionalities provided by different social coding platforms. In summary, we developed an algorithm to detect cross-platform forks from software heritage dataset. We also categorize them. In future, we plan to conduct a larger scale analysis alongside interviews with the developers to understand the pros and cons of different platforms, help stakeholders to make deliberate decisions on choosing code hosting platforms, and help platform providers to better facilitate social coding activities. Thank you.